students, welcome back to 2D video game design. Today we are going to add on to our platformer by actually adding platforms. So first thing, I went and designed a couple of platforms, and in my sprites I've got this blue platform kind of looking like a mushroom type platform, and then I made a thin platform that I'll be able to jump on. And our two goals today are we want to make a moving platform and we want to be able to make a jump through platform. So let's go ahead and get started with the jump through platform. That'll be the simpler one. So I'm going to go ahead and create a 2D object that is a sprite, and I'm going to call this the jump through platform. Okay, and then, oops, didn't actually. There we go. All right, and now let's go to the scene. There it is right there. Let's go ahead and I will use my thin platform here for my sprite. Okay, that's not as thin as I had intended it to be, so let's go ahead and scale it down. Go. Okay, and I'm just going to move it over here a little bit. All right, now in order for it to be a platform, I need for it to interact with my player. So let's go ahead and let's add on a rigid body 2D. This is going to be a kinematic body because I don't want gravity to affect it. Let's go ahead and add a box collider 2D. And that's nice and tight around the sprite. So let's go ahead and make sure that works. Okay, so I'm going to go ahead and jump and, oh, I fell down. Okay, so that reaction right there is because right now my player can rotate when it runs into things. So right here in the rigid body, I can go to constraints and say freeze the rotation along the Z axis, and that'll make it so I can't fall down like that. Of course, if that's something that you want, great. But yeah, there. I can get on top of it. Actually, let me lower it a little bit so I can demonstrate something. Okay, so if I jump on top of it, I can land on top of it and stay. However, I don't get rid of my jump animation. So if I go down here, now my jump animation ends. And the reason for that is because my jump animation only ends when I hit a sprite that's tagged with the ground. So I can fix that by for now, I'll do a quick fix and just tell it that the jump through platform is ground. There we go. And now my animation works well and it ends properly. So for the next thing, I'm going to move this above me, and then I'm going to go to the player and I'm going to increase the jump force. That way I can jump straight through this. So I think 5 should do it. Short, that's okay. We'll just move this up a little bit more. Okay, right there. Now if I jump, I hit my head on this, as you would expect. Now what I want is to have the effect of being able to jump through it and land on top of it. So in order to do that, I'm going to go to my platform and I'm going to add a component to it. And the component that we want to add is the platform effector 2D. So this platform effector is going to make it so we can jump through it by making it so collisions only happen on a specific part of the platform. So right here, this is the platform effector. And then if you go up to your box collider, you'll see this piece that says used by effector. So this box collider right here will be the one that is used by the effector. And if you look right there, you'll see that it made this half circle. And what that means is that everything in this half circle is where the collisions will actually register. So underneath, that collision won't happen, but then when I land on top of it, it will. Okay, so let me go ahead and jump just like that. And now I can jump through the platform and land on top of it. Now, another very common action in a platformer game is for you to be able to drop through a platform that you've landed on. So in this case, I want to be able to push down, and when I'm pressing down, I should be able to drop through the platform. So what I'm going to do is make it so if I press down, this semicircle is going to switch to the bottom half of the platform here. So if you look here, right here, I've got rotational offset, and if I mess with this, you can see that I can change the angle at which the effector is pointing. So I'm going to set it back to 0. And so basically I want to write some code that makes it so if I'm not pressing down, the rotational offset is 0. And if I am pressing down, the rotational offset is 180 degrees. So in order to do that, let me jump into my script section and create a new C# script. And I will call this the JumpThrough platform. Okay, I'm going to go ahead and put this here. And let's go ahead and open up our script. Okay, so the first thing is that I want to be able to change my effector, so I have to create a variable that's going to change it. So this is a private platform effector, 2D, and I'm just going to call that effector. Now in the start, I want to be able to get the effector through script. So I'm going to say that the effector is equal to get component platform effector 2D, end it with parentheses because it's a method. There we go. All right, so now the next thing is within the update, every frame, I want to check to see if I'm pressing down. And remember, I can do that by pressing S, or I can do it by pressing the down key if I use the input.getAxis command. So if input.getAxis, I want to get the vertical axis. And I want to know if it's negative, that would mean that I'm pressing down. So if input get axis vertical is less than 0, then effector dot rotational offset is now equal to 180 degrees. Else, so if the vertical axis is 0 or greater, then effector dot rotational offset is equal to 0. Let's push Control S to save that. And let's go test it out. Okay, so now I'm over here and I can jump through and I land on top of it, and then I'm going to press S to make it go down. There we go. Now I can jump on top of it and land, and then press the down key to drop down. Now, while I'm at it, this is the first asset that I've made that I might want more than one of. So I'm going to go ahead and create a folder, and I'll call this one prefabs. Let's go ahead and make this one a prefab by clicking it and just dragging it in here. Okay, so now I've got my prefab, and now I can make several more of these, and I can start making a level. Okay, so now I can jump here, I can land on it, and I can jump on the next one. Now I run into the problem that I've gone off the screen. So a really easy way to solve this is to make the camera follow the player. And a really easy way to do that is to just take the camera and parent it to the player. So now if I try to go through this, you can go here and you see that the camera is now following the player. The player's staying in a single position right now, and we can do something about that later on. Camera controls a whole other thing. Anyway, that's it for our jump through platform. Let's go ahead and get started on a moving platform. So in order to make a moving platform, I'm going to start off by making the same sprite. So we'll call this one a moving platform. And while I'm at it, let's go ahead and tag it with ground. And I forgot to press enter here. Moving platform. It's tagged with ground. And then in my sprites, let's go ahead and use the blue platform. And just like the other one, that's way too big. So let's scale this guy down to about there. Okay, so same as the other one, let's give it a rigid body. And this is going to be kinematic. And then let's also give it a box collider. Okay, so now I should be able to just run up and jump on top of this. There we go. And we're good. Now the next thing I want to be able to do is to make this move back and forth. And in order to do that, there are a couple different things we could do. We could tell it move forward for a little while and then turn around and go backwards. However, that creates a very jerky, unnatural movement. And think of it as if we had a specific speed, say 10 miles per hour. If I said go 10 miles per hour to the right for 3 seconds and 10 miles per hour to the left for 3 seconds, you would have something that goes back and forth. However, it would have this weird instant where it instantly goes from moving right to moving left. We want to make a more natural movement here by having it slow down and then gradually turn around. So in order to do that, we're going to get a little bit into the math behind this. We're going to use something called a sine wave. Now a sine wave looks like this. So in our context, right here on the middle line, that would be our origin position, and then we would move away from the origin and then gradually stop, and then turn around, head back to the origin, keep passing it, and then slow down and gradually stop, and then we would repeat. So, couple things. This is a basic sine graph, y equals sine x. And if we don't modify it at all, here's what's going to happen. It's going to start here at the origin, and then it's going to move 1 away, and then it's going to come back to the origin, and then it's going to move 1 in the other direction. Now, Changing this value is very, very easy, and in terms of trigonometry, this is something that we would call amplitude. Amplitude is how far away it gets from the origin, and all we have to do is take the entire function and multiply it by however far away we want it to move. So for example, if we wanted it to move 5 away from the origin, we would just do 5 times sine x, and now you see that it moves all the way up to 5 and all the way down to -5. In our case, that'll move left and right. Now, the other thing is, how long does it take to repeat? Here's where we're going to talk about the speed of our platform. So this is going to go all the way up, back to the middle, all the way down, back to the middle. This one repetition right here that it takes to get back to its starting point is what we call in math a period. That's how long it takes to repeat. Now, in this period, if we don't mess with it at all, the period is 2 pi or 6.28. So that means from the start to the finish, if I don't mess with it at all, it will take 6.28 seconds to repeat. So there's a trick to this. What I want to do is get it to a more controllable number, like 1. Because if I can get it to 1 second to repeat, then I can just multiply that by anything that I want. So here's the thing, I'm going to put parentheses around this right here. And if I speed it up by a factor of 6.28, now you can see that it's repeating. It goes up, it goes down, and then it goes back up. And we see that it takes exactly 1 second. And I say exactly, it's 1.001. Because I'm using 6.28 for pi instead of proper irrational number. Now, if you wanted to use 2 pi, if that accuracy is important to you, you could actually do 2 pi, and now it's actually right at 1. There is a way to do that in Unity, but I think for our purposes, 6.28 is going to be sufficient. Now, what if I wanted it to be 3 seconds? Exactly 3 seconds. Well, now what I'm going to do is I sped it up by a factor of 6.28, and now I want to slow it down until it's 3 seconds. So I'm going to take that 6.28, and then I'm going to divide it by however much I want it to be. For example, 3. Okay, and so now you see that the amount of time that it takes to repeat is 3 seconds. Now, I'm going to rewrite that equation in a way that we can control. We'll say y is equal to a for amplitude times sine of 6.28 divided by p for the period times x. Okay, and so now we can see that if we mess with these variables, I can say, okay, I want the amplitude to be 4 and I want the period to be 7. Oops. And now I see, okay, the amplitude, it is going up to 4 and it is repeating itself right here at 7. So it'll go 4 in each direction away from the origin, and it'll take 7 seconds to repeat using this formula. So let's go ahead and go back to Unity and we'll apply this. Now, in order to make this move, I'm going to need to be able to control it through script. So let's go ahead and create another script. C# script, and we will call this the moving platform. Okay, now it's created, but it didn't open it. Let's try that again. Here we go. Okay, so the first thing that I want to do is I want to record my starting position. So I will have a private vector2 called starting position. And then as soon as I start, I can say starting position. Is equal to whatever my transform is, dot position. Now, in order to move it, we're going to change the value of the transform position. Transform dot position. That's going to be equal to, let's take the starting position. Now, remember, the starting position is a vector 2, and so in order to change the starting position, I need to add another vector 2 to it. So a new vector 2. And then the vector 2 consists of an x and a y, one for the vertical component and one for the horizontal component. So what I can do here is, let's make one that moves horizontally first. In order to make it move, let's go into the math library and get the sine function. And then the input for the sine function is going to be the amount of time that's passed, which we will do by saying time.time. Now, this is the default sine function. We haven't messed with the amplitude and we haven't messed with the period, but let's go ahead and see what exactly that does. Let's click Control S and then go into our game. Now, nothing happened. And I know why. It's because I didn't put the moving platform script onto my actual object. So let's go ahead and put the moving platform script onto my sprite, and let's try that again. There we go. Get this nice smooth movement of the moving platform. I can jump down onto it. Can I? Oop, almost landed it. Yay! Uh-oh. Okay, now I'm getting this weird effect here that I can land on it, but it slides out from underneath me. Okay, so let's go ahead and take care of the period and the amplitude first, and then we will go back and fix that sliding problem. Okay, so what I want to do here is take this whole equation right here, and I'm going to multiply it by a variable called amplitude. Now, red underline there, and that's because we never defined amplitude. So let's go up here, and we will make a public float amplitude. And let's set that to a default of 1. And let's also do a public float period. And let's also set that to 1. And then we can adjust it in Unity. But we're going to go ahead and say amplitude times math.sine. And let's go ahead and save that and then head back into Unity. Okay, so here it is. Oh, it's not open. That's why. There we go. All right, so let's go ahead and change the amplitude here to 0.25. And what we should see here is that now that I've changed it to 0.25, that it should be moving much tighter. There we go. Now you see that it's moving just a little bit each way. Now it's going really slow, because it's still taking 6.28 seconds to repeat that. So let's try to get it so it takes 3 seconds to repeat. So what I want to do is take this time.time and I'm going to multiply it by, just like we said earlier, 6.28, we'll put an F on there so it's a float, divided by whatever the period is. Control S to save. Let's go back and let's make that move. Okay, so I'm gonna take the period. Let's go ahead and adjust it to be 3 seconds instead of 6 seconds. Let's play it and see how that looks. There we go. That's a much quicker movement. And if I look at where it is on the left, 1, 2, 3. There we go. It takes exactly 3 seconds for it to repeat itself. So now let's go ahead and take care of the issue that I just slide on this. I want to be able to move along with it. Now, just like how we parented the camera to the player, what I want to do here is when the player is on top of the platform, I want the player to be parented by the platform. So the platform will be the parent of the player as long as the player is touching the top of it. So let's go to the moving platform. And what I want to do is create an onCollisionEnter method. So we can say private void onCollisionEnter2D, and this takes the argument collision2d.collision. So in this case, the collision is the player. The player is landing on top of it. So I want to say if it gets collided with the player. So I just want to go back to my player real quick, and I want to give it a tag. This is the player. That way the platform can know it's being collided with by the player. Let's go back into the script. If collision.gameObject.compareTag, if the tag is player, then we want to set the player's parent to be the platform. So collision.gameObject.transform.setParent. And what do I want to set the parent to? I want to set it to transform. And in this case, what we're saying is take the collision object, which is the player, take its transform and set its parent to transform. And when we say transform without any specification, it means the transform of the object that this script is attached to, which is the platform. So if I test this, then we get this effect. Okay, let's go ahead and jump on top of it. And now you can see I can move back and forth with it. However, there is an issue with this, and let me show you what it is. Let's go ahead and leave, and we are still moving left and right in sync with the platform. That's because we are still parented to the platform even though we've jumped off of it. So what I have to do here is say what happens when I jump off of it. And it's a really simple operation here because it's almost the same thing as the onCollisionEnter, and we're going to use the onCollisionExit2D. What we want to say is if the collision that's exiting is the player, then set the player's parent to nothing. So if the collision.gameObject.compareTag is the player, then collision.gameObject.transform.setParent. We want to set the parent if they jump off of the platform to nothing, which is null. Okay, so now let's see how that works. Got my platform here. I'm going to jump on top of it. Now that I've landed on it, I can move back and forth with it, and then I can get off, and now there's no movement there anymore. So now I've got some platforms that I can jump on, and a glitchy wall right there, and falling into eternity.